Today's topic of discussion is pointer part 2. We have already discussed about the pointers in the previous video. Hope you have gone through the video. Now in pointer part 1 we have discussed about the introduction to the pointer, what is a pointer variable and how it can be used, and what is the back process which goes through in case of initializing or using a pointer variable. Now in the part 2 we'll discuss about the increment decrement of a pointer, and we'll take help of one example in which we'll demonstrate how the pointer variable affects the program and what are the things which we have to change and what are the effects of using a pointer variable within a program. So hope you will enjoy the video. So let's start. So today it's pointer part 2. Pointers part 2. So hope you have gone through the pointer part 1 video, because if you have not gone through the part 1 then it will be not possible to understand the part 2. So let's start. So in pointer part 1 we have discussed that what is a pointer variable. We'll just go through a quick recap that pointer is a variable. It is a type of variable which holds or which stores the address of another variable. Another variable that could be of integer type, that could be of float type, that could be of character type. Any type of variable that could be the pointer variable. The main principle or main work of a pointer variable is to store the value of another variable. So we have already discussed how the values are stored and how the values can be there in a pointer variable. Now let us consider a situation where we'll take one example so it will be easier to understand. We take one variable integer type, variable of integer type as int I equals to 10. Now we'll take a pointer variable star a and we'll just say a equals to ampersand of I, so that the value of the address of I could be the value of a. Now if we want to increment or decrement, so let's start today with the increment and decrement of a pointer. Increment and decrement of a pointer. So this much portion of the program is okay, because we have already seen that what are the scenario going in the back process. But from here, if we want to increment the pointer, so we need to write a double plus, because we know, we have seen in the increment decrement section that if we write double plus, that means it should be incremented by 1. Now what will be the scenario here? So let us draw the memory map. Here the value of I is equals to 10, and let the address be 61234. Now this is a pointer variable which is stored here also. So a is the name of that pointer variable, and what is the value of that pointer variable? That will be 61234. So there should be an address for this variable also. Let this be 61236. Now what happens when we are trying to increment the value of the pointer by 1? So what is the value of the pointer right now? 61234. Right? Is it true or not? Yes, it is of course true, because the value of the pointer variable a is the address of I. So this is 61234. So what will be the next value? A double plus means it gets incremented by 1. No, now what will be the next value? So it should be, if we do a double plus, that means equals to a plus 1, that means 61234 and 61234 plus 1. So it will be equals to 61235. This is our normal concept, but the case here is not like this, because it is a pointer variable. It stores the memory. So it depends, the increment or decrement depends on the type of the pointer variable. Type of the pointer variable means Here, if we see the pointer variable A is storing the address of an integer variable. So this is an integer pointer variable. So we have already discussed that in integer it holds 2 bytes of memory in the memory location. So whenever you are going to increment, whenever you are going to increment the value of a pointer variable, so it will be incremented as per the type. That means if a equals to 61234, if we do a plus plus, then it will be 61234 plus 2, so it will be 61236. This is how it works, because pointer is a, I'll repeat it once again, that pointer is a type of variable which holds or which stores the address of an integer. So the pointer variable always deals with the address. There is no question of any value in it. The value is also an address of another variable. Remember that. So whenever we are going to introduce with any increment or decrement within the pointer variable, so the address will be decremented. And how the address will be decremented, incremented or decremented, what kind of pointer variable it is, depending on that the value, the increment or decrement will happen. Here we have taken integer, as we know that integer holds 2 bytes in memory, so it will be incremented by 2. Whereas if we take this int value as let it be float, so it will be, so it should also be a float a, so it will definitely incremented by, then it will be definitely incremented by 4, so it will be 61238, because we know that the float variable holds 4 bytes of memory in the memory location. Whereas if we use character variable, that is char I, then it should also be char, so it will be, whenever we are going to introduce the increment here, so it will be incremented by 1 only, because we know that it holds only 1 byte in the memory location. So this is how it works. The same thing will be followed at decrement also. Now here we can do the post increment or the pre increment. The logic remains the same, but the increment logic will also be imposed upon, because in post increment we have to increment first, then we will proceed further, and in pre increment we have to increment first, then we can proceed, and the post increment will increment further before execution, after one execution. So as you all are aware of this post and pre increment, so we are not going in detail about them. So this is how the increment of a pointer works. So I'll repeat in a quick recap that if we use a pointer variable, then how it will be incremented or decremented, that can be determined by seeing that what kind of pointer variable it is. If it is an integer type of pointer variable, then we are doing the increment, then it will be incremented by 2 bytes. If it is a float kind of pointer variable, then it will be incremented by 4 or decremented by 4 bytes. Or it is an integer character variable, character type of pointer variable, then it will be incremented or decremented by 1 bytes. This is how it works. Hope you have understood the concept of increment and decrement of a pointer. Write it down if needed. So we'll go for the next example to demonstrate how the pointer variables affect in program, and what are the things which we need to change in case of writing a program by using a pointer variable. Please remember and understand the things, understand the concept which we are going to tell right now very carefully, because it will be very helpful. We'll take one example from this book. Let us see that int I equals to 3. Now if we take int star j equals to ampersand I, now printf address of I equals to %u, comma ampersand I, printf address of I equals to %u, comma j, printf address of j This refers to address. Address of J is equals to J. Now, the value of J. Let us write as value of J. Now we have written the program and we'll just write down the memory map so it will be easy to understand. So let there be one I which has a value of 3 which is written in the program itself, and let the address of I be 65524 and address of that should be the value of this 65524, and let this be 65522 address of J 65522. Now there are how many lines? 1 2 3 4 5 6 7. So there are 7 lines. We'll write the output and we'll discuss about the outputs in detail. So it will be 65524 for line number 1 2 3 4 5 6 and 7. We'll discuss that. 65524. Now 65524, 65522, 65524, 3 and 3. Okay, let us discuss about the program, whatever we have written, how the outputs are like this. So int I equals to 3, int star j, that means j is a pointer variable. Now in the next line we have written that j is equal to ampersand of I. Ampersand of I, that means the value of I is getting stored in j. So what is the value of the address of I is getting stored in j. So what is the address of I? Address of I is 65524, which is getting stored in j. Now first statement, whatever we have written here is printf that address of I is equals to %u comma ampersand I. We have not seen anything called u before. We have seen D, we have seen C, we have seen F, but we have not seen any u. But in one day in class we have discussed about the signed and unsigned integers. Try to remember that. Signed integers means the integers which can hold both positive and negative values, whereas unsigned integers means it can hold only the positive values. Now in case of pointer, the address of any type of variable can never be negative, so it will always be positive. So in case of printing or writing the address of any kind of variable, then we have to use the unsigned integers. So that is why it is written here as %u. Clear? Now I equals to %u and comma ampersand I. Ampersand I, why it is written? Ampersand of I. Ampersand of I means address of I. Ampersand of I, that is we are also writing it here on here, that ampersand of I, j is equals to ampersand of I. That means that refers to the address of I. So what is the address of I? That is the value of j, 65524. So that is why it is 65524 in the first place. So this thing is explained. Now the second part states that address of I is equals to %u comma j. We have written j here. We are going to bring the address of I, but we are writing j. Why? Because just think that j, what is the value of j? J means the value of j will be printed. What is the value of j? Value of j is the address of I. Value of j which is stored here, that is, these two are same thing. So the value of j is the address of I. That is why we can write this or this. Both are same. So that is why we have written here. So the second thing also clear. Now we are coming to the third line. So that is address of j equals to %u, comma %j. So address of j is equals to %u. Of course, that is an unsigned integer, and we are just writing ampersand of j because we don't have any other value further. So if we had any other pointer variable which was storing the address of this variable, then we could have written like this. But here we have to write that ampersand of j because address of j refers to this only. And we are trying to print the address, that is why we have given unsigned. So ampersand of j, ampersand of I, ampersand of I refers to the address of I, ampersand of j will definitely refer to the address of j. So what is the address of j? This is the address of j. So this is how it is getting printed. Now coming to the fourth line. It is written the value of j is equals to %u, comma j. We are going to print the value, but we are using u. We are not going to print the address, but still we are using %u. Why? Because it is very prominent that j is a pointer variable. That means value of j is definitely definitely the address of another variable. Just think that if j is a pointer variable, then the value of j is definitely the address of another variable. So it will be an unsigned integer. That is why we have written like this. So I think it is clear now. So we'll move to that is why it is 65524. So these four lines are explained. Now we are going for the fifth one. So printf, it is written that value of I is equals to %d, comma I. So value of I, we are going to print the value of I. Value of I means what? Well, what is the value of I? We have already stated. That is very simple. We have used the same statement again and again in different programs. So value of I is equals to %d, that is I. We are familiar with this statement, and the value is 3. But we can write the same by using different techniques, like value of I equals to %d. That means that is the value of I we want to print, but we are not writing directly I. We are writing star ampersand of I. We are just going here star ampersand of I. What does it mean? It is very important. So many MCQ questions or so many questions come by using these statements, and students are getting confused. What will be the output? So it is very easy to understand. If you understand it properly, then it is very easy to calculate. Just listen. That ampersand of I means what? Address of I. Just remember this. Ampersand of I means address of I. We are using the same statement again and again. Ampersand of I means the address of I. Now star, we are using, that is within bracket, and we are using star before that. Star means always, star here means always the value stored. So what is the total sentence is coming out of this statement? That value stored in address of I. So value stored. We have told that star means value stored, and ampersand I means address of I. Value stored at the address of I. Address of I. So what is, you can directly find out what should be the output. Value stored at address of I. Address of I. What is the address of I? This is the address of I. What is the value stored? 3. In this address, what is the value? 3. In this address, what is the value? This. So the same thing coming out here. I think that should be clear. I'll repeat it once again, that star means value stored, ampersand I means at that address. That means address of I. Ampersand of I, ampersand of B, ampersand of C, that means ampersand of B means address of B, ampersand of C means address of C. This is how it works. So value stored at this address. So what is the value stored at this address? Obviously it is 3. So we can write instead of writing this. Or if you were asked that what will be the output of this statement, so you can easily find out from the this calculation. This is very, very important. So we have gone through the 6 steps, 6 lines. So we'll come to the final thing. That is printf value of I equals to %d, comma star g. What is star g? Star g means we have told that value stored at j. So value stored at j, but it is a unsigned integer, signed integer. So value stored at j. So what is the star j means what? What is the value of j? Value of j is this. So value stored at this address. So 3 is coming like this. Ampersand of I is equal to j. If you just replace this value of j here, the thing remains the same. The things become the same thing. These two are same because we have already written that j is equals to ampersand of I. Just put j here, so it will become star j. So these two statements become same. So that is why output becomes same. This is how pointer works actually. And there are different uses of pointers. Basically, we in our syllabus it will be used in functions. So next topic will be go to statements, then we'll come to the functions. Pointer will play a very prominent role in C programming, and it has several options. So be very careful about the statements whatever we have discussed, about the programs whatever we have discussed, and go through all the notes, go through all the PDFs whatever I have sent. So it will be easier to understand, and please do your work properly. Please go through all the contents, otherwise it will be difficult to proceed further. Hope you are enjoying all the videos and you are understanding whatever I am trying to make you understand. So see you on the next video that will come soon. Thank you.